All right, over there. All right, we're live. Hey, Mr. Linford's class here. Today we are going to be exploring a couple of the review topics in our live stream and starting on the new topic that was assigned today, section 11.1. I will be recording this video and then sharing it with the class right after the live stream. What I figured we'd start with is a review of section 10.7 that was assigned last week, and you had the weekend and Friday to work on it. What I'd like to do is review a couple of the problems, in particular from the exit ticket, and answer any particular questions that you have. If there's anything you'd like me to go over, or anything you'd like me to review, or to explain more of, please let me know. You can let me know in the live chat that we have going on to the side here. Otherwise, feel free to email me questions before these live chats or anything that you'd like me to focus on a little more of. Let's start with section 10.7, and this is solving radical equations. So we started by solving quadratic equations, then we moved into solving rationals. Now we're in solving radicals, and then today you're actually going to go back and learn about other techniques for solving quadratic equations. But let's start by reviewing these radicals. Notice that in this problem, we have the variable x that we want to solve for trapped inside one of the radicals. What we have to do is isolate that x somehow. Well, the first obvious step is to move the terms over that we can. So we have the cube root of x plus 2, and that's going to be equal to a negative 2. Now the question was, how did we get that x outside of the radical? Because that's the thing, we can't work with it until that radical's gone. Well, what's the easy way of getting rid of a cube root? We could just cube both sides. So let's go ahead and cube both of these. We end up with an x plus 2 equaling, now keep in mind, we have to be careful with the sign here. Negative 2 cubed is in fact negative 8. And then this is actually fairly easy to solve. Just subtract 2 again from both sides, and we end up with x equals a negative 10. Now here, all we're doing really is isolating the radical. And then once we have the radical isolated, we raise both sides to a power. That power is, in fact, the index. So we raise both sides to a power to get rid of that root. Now, if you remember from our lecture, we said you might be able to solve this and get an answer, but then you have to go back and you have to check your work. You have to check to make sure we don't have what's called an extraneous solution. Extraneous solutions popped up because we took an equation that had a restricted domain. We took a function, I should say, this thing here, that has a restricted domain, right? If you remember square roots, they, in the real number system, their domains are where the radicand can't be a negative. And even though this is a cube root, we still have a bit of a restricted domain issue here. And then we turned it into a linear equation. That's essentially what all this pre-work was for, was to turn it into a linear equation, which has a domain of negative infinity to infinity. So the trouble is when you go and try to solve some of these, you might end up with solutions. You could do all proper math, but you might end up with solutions that are extraneous. So let's check our work and make sure that we have a solution that we can actually work with and not really kind of what we might call a pseudo answer. So we plug it back in and plug it back into what you started with. The cube root of negative 10 plus 2 plus 5 equaling 3. All right, that's the cube root of negative 8 plus 5 equaling 3. Well, what's the cube root of negative 8? I'm even going to take this in my calculator. I'm going to type it in right now, and I'd like you to try doing the same, because you will see that when you take the cube root of negative 8, you do in fact get negative 2. What I want to say here, and that's a true answer, by the way, what I want to say here is the cube root of negative 8 is not the same thing as, you get the same answer, but these aren't saying the same thing, okay? What I'm asking you to do right here is to cube negative 8. I'm not saying cube 8 and then make it negative. Okay? They would get you the same answer, yeah, -2, but again, they ask different things here. But the important thing is we have a solution. This works. It is not extraneous. So let's go ahead and practice the second problem now. In this problem, we had 2 radicals. Now remember, the trick with this was you're going to have to square both sides. That's the only way to get rid of radicals, is squaring them or cubing them or whatever. So here we're dealing with square roots, so I got to square both sides. We said make sure that you have a radical on each side. Don't have multiple radicals on one side. You could, but it's a lot more lengthy and messy. We said it's better if you have a radical on each side. So let's go ahead and square both sides. Well, the left-hand side's pretty easy. It's just 5x plus 4. But the right-hand side, this is going to have to be simplified by FOIL or box method. So I'm going to have to do the box method here. 1 and the square root of 5x minus 3. And then we have 1 and the square root of 5x minus 3. I'm going to set up the box really quick. And let's try to fill in these values. 1 times 1 is 1. And then let's go over here. The square root of 5x minus 3 times the root 5x minus 3 is just 5x minus 3. But then we have to fill in the corner boxes. So we just end up with a root 5x minus 3 and root 5x minus 3. So what is our answer after we multiply this? Well, let's take a look at the things not in the radical. We have a 5x. We have a -3 and a +1, so that's -2. Now let's take a look at the things inside the radicals. Well, since they're the same and we're adding them together, that means we have 2 root 5x minus 3's. So hopefully you're seeing how we not only did the multiplication, but how we combined the values together. And this is what we're going to end up with. It's important to recognize that we are still going to have another radical in this problem, and that's okay. What we do when you have multiple radicals and you square both sides, the idea is that you eliminate one of the radicals at a time. Since we did that here, now the next step is going to be to try to eliminate this radical. So let's move some values over and let's combine some like terms. I can subtract 5x from both sides, and in fact that'll actually cancel out on both sides. I can add 2 over. We would end up with a 6 equaling 2 square root 5x minus 3. I could leave things as is, but why not just go ahead and divide 2 over again? We get a 3 equaling the square root of 5x minus 3. Was it necessary to divide this 2 over? No, but made it easier. All right, now we have the radical isolated again. I can't move anything else over because everything else is trapped in that radical. So to get rid of it, I'm just going to square both sides again. So we end up with a 9 equaling a 5x minus 3. All right, what we're doing here is one step at a time, we're eliminating radicals. And that's the central idea. You just keep raising it to a power and you'll eliminate them one at a time. So once we have this, we can easily add 3 to both sides. We end up with a 12 equaling 5x. Divide by 5. X equals 12/5. All right, well, kind of messy, but let's take a look and see if this is the actual solution. So I'm going to check this. It's good to have scrap paper to check your solution on, but I'll just do it to the side here. We're going to check by plugging 12/5 into the original problem. We have the square root of 5 times 12/5. Oh gosh, this is this is going to be too messy. Maybe I'll move it down here. I have the square root of 5 times 12/5 plus 4. And then we have 1 plus the square root of 5 times 12/5 minus 3. All right, let's start simplifying and see what we get. We have the square root of 5 times 12 fifths is just 12 plus 4, but 12 plus 4 is just 16. And then that's equal to 1 plus the square root of 5 times 12 fifths is 12, minus 3. Well, 12 minus 3, we can simplify that. That's just going to be a 9. All right, so really we have the square root of 16, that's just a 4. And then we have 1 plus the square root of 9. Well, the square root of 9 is just a 3. Hey, what do you know? We get 4 on both sides. So in fact, 12 fifths is in fact a correct solution for x. It is not extraneous. It does in fact work. Now let's go ahead and let's try a couple more review problems. These came to us from the independent practice. Notice that they're pretty much structured the same way, but they're of different indices, so we're going to be working with different exponents. What we first want to do is isolate the radical. So let's go ahead and subtract 2 from both sides. We end up with the cube root of k plus 18 equaling negative 2. Now, we can't move anything else over because it's all trapped inside the radical. So let's raise both sides to the third power. That's going to cancel the radical out, so we have k plus 18 equaling, okay, negative 2 cubed is negative 8. So if I subtract 18 from both sides, we get k is equal to negative 26. Let's go ahead and check that answer. I always like to swap colors whenever I check answers here. If my stylus will ever connect, there we go. I would suggest having some scrap paper or trying to do this a little organized as best you can. So let's see, the cube root of negative 26 plus 18 plus 2 equals 0. That's what we want to show. So this is going to be the cube root of negative 26 and 18 is negative 8 plus 2 equals 0. Well, the cube root of negative 8, again, you could check that in your calculator, but in fact, you're going to get a negative 2 plus 2. And that, in fact, does equal 0. So again, we do have a full solution here. It is not extraneous. It does work when we check it. Let's check the next one now. Again, this one going to be a little different. It's raised to a fourth power. Now, when we solve this problem, notice that there's nothing to add over or subtract over. We already have the radical isolated. So we'll raise both sides to the fourth power. We end up with an x plus 16. Be careful on the right-hand side. I'm still seeing people make this mistake. It's negative 4 to the fourth power. You could try to type that into your calculator, and you should end up with a 256. Remember that negative 4 to the fourth power is not the same as this expression, negative 4 raised to the fourth. They're different. This problem on the left-hand side gets you 256. That's what you needed to type into your calculator. The other one gets you negative 256. Okay, remember, exponents only affect what they're immediately touching. If you mean to take negative 4 to the fourth power, if you mean to take the whole value of negative 4 and raise it to the fourth power, you need to wrap it in parentheses. Otherwise, you're saying just take 4 to the fourth power and then make it negative. So remember that distinct difference here. And your calculator knows this. Just so long as you type it in with parentheses, you'll be good. All we need to do now is subtract 16 from both sides, and we end up with x equaling, let's see, 256 minus 16 is 240, and we should be good. Oh, but wait a minute, Linford, wait a minute. You got to check your work. Must check our solution here. So let's see what we get. I'm going to plug 240 back in, so I have the fourth root of 240 plus 16 equaling negative 4. This is what I want to show is true. So let's see. We need the fourth root of 256. I need to show that's negative 4. Well, I could take 256, and I'm going to raise that to the 1/4 power, or take the 4th root of it, same thing, and I end up with a 4 equaling -4. Here's a problem for us. I end up with this getting me a +4. So it doesn't work. They're going to be extraneous solutions here. Now, some people are saying, wait a minute, Linford, wait a minute. Isn't this the positive or the negative? Can it be two possible solutions? Well, yes, it can, right? And it's fair to say that 4 to the 4th is 256, and -4 to the 4th is 256. Both of these are, in fact, correct solutions. That's totally allowed. But some people are saying, well, why didn't you pick the -4? Why did you pick the +4? Well, part of the reason is because this symbol generally says do, in fact, pick the positive version. When you're trying to evaluate for a number, yes, you can get plus or minus. But the trouble here is that the positive one doesn't work. Okay? You're saying skip the positive and just do the negative. Well, that's kind of a bit of an issue for us. Partially because we oftentimes pick the positive first. There's a very complicated reason for it. And it comes down to, I'll say in case anyone wants to look into it a little more, it comes down to what I would probably relate to roots of unity. And we could talk about this a little more if you have more deep questions about it. But just realize that when we're trying to evaluate this, generally speaking, this symbol, when I say take the root of something, means to take the positive root first and then the negative. Well, since the positive root doesn't work here, it's not going to work. So we're going to say this is extraneous. We don't want to leave it up to one or the other. We want to say the first thing that we take is the positive, and then the second thing we take is the negative. Well, if it doesn't work for the first thing, then forget it, okay? I don't want it to leave it up to chance where one might work, one might not work. We're just going to stick with that first answer. Now, that's because this is an even root. Notice in the previous problem, I had the cube root of -8, and I said that gave me -2, because that's true. It is -2, right? +2 would not be a solution here. So that's, in fact, there's only one specific real answer that works here, real number answer that works here. So that's why this problem was a little different, because it just had the one solution. This problem has two possible real number solutions. In fact, it actually has 4 solutions, but that's for another story. All right, let's go ahead and keep practicing this. Let's try now when we have multiple roots. In this problem, our goal is to square both sides, right? Our goal is to get rid of each radical. And we said to do that, you got to square both sides, but it's only going to eliminate one at a time. So what we'll first need to do is make sure that roots are on each side. There's one root on the left and one root on the right. Little side note for ourselves, make sure the more complicated root is by itself. By that, I mean, look at the radicand that has a lot more to it. Make sure that's alone on one of the sides. Because what we really want to say here, of course, now my iPad is going to kick out on us. What we really are trying to say with this is that if I'm going to have to do the box method on this whole thing, this whole problem, I don't want to have to necessarily multiply or FOIL out a very complicated radicand. Instead, I want to make sure that that radicand can very easily cancel out. Sorry, I'm having to reboot my iPad really quick, but that's okay. We'll get right back to this problem. Again, what I'm suggesting here is that we really leave the more complicated square root alone, because when I just square both sides, if the more complicated one's left by itself, it just becomes its own radicand. That's pretty easy. All right, just reconnecting my iPad. Of course, it works perfectly all weekend, and then now is the time when it wants to disconnect. I mentioned a minute ago the idea about solutions to square roots, cube roots, fourth roots. One thing I will say is that the index actually tells us how many solutions there are to a root. So if you have a square root, remember we have two possible values. You have a positive and a negative version, but we generally start with the positive, then go to the negative. And there's a reason for that. There's actually it's a little complicated, but there's a deeper mathematical reason for that. Then we have cube roots and fourth roots. One of the things I will say is that, in fact, a cube root has 3 solutions, and a fourth root has 4 solutions. The index actually tells us how many solutions there are to the problem. And there's a reason for that. Again, if you want to know a little more about that, feel free to let me know. You can come by my office hours and we can talk about it. Well, it looks like I'm still having issues connecting my iPad. So what I'm going to do is I'm going to end the live stream really quick. I'm going to reboot my computer, and then I'll come back in about, give me 5 minutes, and hopefully we'll be set to go again. Sorry about this, but give me just 5 minutes, and we'll be right back.